All right, good afternoon, everybody. This is Mr. Shua coming at you again with another video. This time, I'm going to go through the 2019 TestNav SOL practice questions. Virginia has changed the standards for the SOL in 2016. So it's more increased standards. Anyway, what I'm going to do in this video is I'm going to go through the test practice questions that they have for the 2019 test nav here, and hopefully this should help you to pass the Algebra 1 SOL here. All right. So anyway, learners, you see Mathematics 2009, which used to be the standards, now it's 2016. And I'm going to start with the Algebra 1, the 2016 practice. So there's 28 questions for the Algebra 1 here. Let's just jump right into them here. Let's see what's going on here. I agree. Okay, let's start section 1. So it says, what is the value of this expression when a equals 8, b is 16, and c is -4? And they give us 5 times the cube root of a minus c, the square root of b, plus 9. Now, I've worked out these questions previously, so I'm going to go to where I worked them out previously here. Now, here, matter of fact, all right, so 5 times the cube root of a is 8, so that's 5 times the cube root of 8, minus c, which is -4, so minus -4, times the square root of b, the square root of, and b is 16, the square root of b, plus 9. Now, 5 times the cube root of 8 is 2, so that's 5 times 2. Negative of -4 is basically just +4. The square root of 16 is 4 plus 9. So 5 times 2 is 10, plus 4 times 4 is 16 plus 9. That's 26 plus 9, 35. Answer B, 35. Okay? 35. Next question. Which represents this expression in its simplest form? We have 15 times x to the -2 cubed over 3 times x to the -4 raised to the -3 power. Go back here, and what we'll do here, 15 times x to the -3. If we multiply these two here, that's simply going to become 15 times x to the -6. If we multiply these two here, that's just going to be 3 times x to the 12. Now, using the law of exponents, whenever you have the same base, x, but the exponents are different, you subtract the exponents. So this is going to be x to the -6 minus 12, which is x to the -18. And anytime you have negative exponents, you move them to the opposite side to make them positive. So this is 5 over x to the 18, which is choice D. Let's move on. What is the quotient of 15x squared minus x minus 12 and 3x plus 2? Assume the denominator does not equal 0. And basically, they're just saying, assuming that there is an answer for this. So let me go to where I've actually worked this out. This is simply just division of polynomials. So here it is, 3x plus 2 is dividing 15x squared minus 8x plus x. Now, what can I multiply 3x by to get 15x squared? Well, I multiply it by 5x. And if I multiply 5x by 3x plus 2, I get 5x squared plus 10x. Then, when we're doing division of polynomials, we simply subtract that amount. So I track that amount, and I get -18x. I bring down to 12. Now, what can I multiply 3x by to get -18x? Well, negative 6. And if I multiply negative 6 times 3x plus 2, I would get negative 18x plus 12. Then again, with division of polynomials, I simply switch the signs. 0 denominator, it's even, and our answer is 5x minus 6, because 5x minus 6 times 3x plus 2 indeed gives you 15x squared minus 8x minus 12. So your answer is D, 5x plus 6. Let's move on. Okay, when factored completely, identify the factors of this polynomial. 9x squared minus 39x minus 30. Okay, so let us scroll down here. First thing we need to recognize that I can factor a 3 out of each of those terms. And when I do that, I'm left with a 3x squared minus 13x minus 10. Then using the AC method of factoring, multiplying the A times the C, I get negative 30x squared. So I look for factors of 30 which can give me 13 as my middle term. And negative 15 and positive 2 would be those indicators. So I turned this 3-term polynomial, 3x squared minus 13x minus 10, into a 4-term polynomial, 3x squared minus 15x plus 2x plus 10. And anytime you have a 4-term polynomial, you simply factor by grouping, which means take the first 2, place them in a grouping factor, take the second 2, place them in a grouping factor. So here for 3x squared minus 15x, I can factor a 3x out of each. And that leaves me with an x minus 5. Here, with the 2x minus 10, I can factor a 2 out, and that leaves me an x minus 5. Since x minus 5 appears in the both parentheses, I know that is one of my factors. Then I simply take these two and put them together, the 3x plus 2, and then don't forget to factor or bring down the 3, which I initially factored out in the beginning. So my factors are 3, x minus 5, and 3x plus 2, and I would simply highlight each of those. So my 3, my x minus 5, and my 3x plus 2. All right, let's move on here. When x is greater than 0 and y is greater than 0, which expression is equivalent to the square root of 180 x to the 9th, y to the 16th in its simplest form? Okay, let's see here. What I usually tell my students to do is take whatever this problem is and split it into 2 separate square roots. And what you do is everything which is a perfect square, place under your first radical. Everything which is not a perfect square, place under your second radical. Now, 180, let's deal with that. What are 2 numbers that multiply to 180? One of them is a perfect square. Well, 36 and 5. 36 times 5 is 180. 36 is a perfect square, so I place that under my first radical. The 5 is not a perfect square, it goes under my second radical. X to the 9th. Now remember, any even number exponent is a perfect square. So I can take 8 of these x's. X to the 8th, that's a perfect square. The remaining x goes under here, which is not a perfect square. Y to the 16th, that's even, that's a perfect square, so it goes here. Now, if I just simply take the square root of this, the square root of 36 is 6. Square root of x to the 8th is x to the 4th. The square root of y to the 16th is y to the 8th. Then just bring over what does not perfectly factor out. So 6x to the 4th, y to the 8th, times 5x, which is answer D. There we go. Next. What is the cubed root of 3,456 in its simplest form? Okay. So what you can do is, if you multiply everything, since it's cube root, whatever this number is, you basically multiply by that power to see if it gives you the number back. So for example, starting with this 2, the cube root of 12. If I multiply 2 times cube, that's 8. The cube root of 12 cubed is just 12. 8 times 12 is 96. Again, if you want to find out which one of these will give it to you. Now, look here. 6, the cube root of 16. If I do 6 cubed is 216. And the cube root of 16 cubed is 16. And if I multiply 216 times 16, that gives me 3,456. So there's my answer here. Now, depending on whatever this number is right here in the radical, you multiply it by that power and just check to see when it gives you this back. So option B is our answer. And we go here. Next. For which value of x does the cube root of x simplify to be 5 the cube root of 7? All you need to do is plug in each of these for the x, see if it gives you this one back. Okay? So, now, the cube root of 35, well, that's already simplified. Can't do anything else with that. Cube root of 245 is also simplified. Can't get you anything else with that. However, the cube root of 875 can break down as the cube root of 125 times the cube root of 7, because 125 times 7 is 875. The cube root of 125 is simply 5. Cube root of 7 is already simplified, so 5 cube root 7. Just in case you're interested with the 715, that breaks down to 343 times 5, and that gives you 7 cube root of 5. That's not the one we want. So C, 875. That's the one we want. Let's move on. Drag the answers to the correct boxes. Each answer may be used more than one time. Complete this equation to create a true statement. 4 square root of 2 times 2 square root of 3. Well, basically all you're doing here, you're going to multiply the integers, the 4 times 2, which will give you 8. Then you multiply the radicals. Radical 2 times radical 3, radical 6. So your answer is 8 radical 6. So I would simply put the 8 here for 8, and then radical 6 right here. There we go. All right. Now, Michelle correctly solved a linear equation, and the last line of her work was 1 equals 2. Which statement best describes the solution to the equation Michelle was solving? So whenever you're working out an equation and you get 2 different answers on the side of the equal sign, no solution. If you get the same number on both sides of the equation, the answer would be infinitely many solutions. But in this case, the answer is different. No solution. That's all. Pretty simple. Equation has no solutions. What are the solutions to the equation 2x squared plus 5x plus 3 equals 0? Well, there's a couple of ways that you could solve that. Let's scroll down here. Now, quadratic formula is probably one of the easiest. You could graph it. You could also, well, not necessarily graph it, but you could also use completing the square. But let's use the quadratic formula, which is one of the simplest means, which is x equals the negative of b plus or minus the square root of b squared minus 4ac all over 2a. And in this case, the a is the 2, the b is the 5, and the c is the 3. Plugging all of this into the quadratic formula, well, negative 5 plus or minus the square root of 5 squared minus 4 times 2 times 3 all over 2 times 2 gets us here to negative 5 plus or minus 1 over 4. So we break that into 2 separate equations. Negative 5 plus 1 is negative 4. Negative 4 over 4 is negative 1. Then negative 5 minus 1 is negative 6. Negative 6 over 4 is 3 halves. So negative 1 and 3 halves. 3 halves, negative 1. Option C. Type an inequality in the statement in the box. Use the less than or greater than for the inequality symbol. Solve for x. All right. So, first thing we do, combine like terms. If I combine 6x and minus 13x, I would get a negative 7x. Minus 11 is less than 7 minus 5x. Then, if I add 7x on both sides of the equation, I would get a negative 11, which is less than 7. Plus 2x. I don't know why I wrote a minus 2x. That's plus 2x. Then, if I simply put minus 7 on both sides here, then I have a negative 18 divided by 2x. Then negative 18 minus 2 is negative 9, which is less than x, or if I flip it around, x is greater than negative 9. Okay, the steps make sense here. All right, so x is greater than negative 9. Yep. And we go on to the next one here. All right. Select array, then drag the endpoint to the correct location on the number line. Grab the solution set to this inequality. All righty. So, we have the negative of x plus 4 minus 2 is greater than 2x plus 6. So here, the negative. Whenever you see a negative sign outside of parentheses, treat the negative sign as if it's a negative one and distribute. So that's a negative x minus 4 minus 2 greater than 2x plus 6. Combine like terms, negative x minus 6 greater than 2x plus 6. If I add 6 on both sides, that's a negative x greater than 2x plus 12. If I subtract 2x both sides, that's a negative 3x is greater than 12. If I divide by negative 3 on both sides, you're dividing by a negative, so the sign, the inequality switches. So that's going to be a x is less than negative 4. X is less than negative 4 is what we should have. So less than, and put this negative 4 right there. Okay, Frank works at a convenience store. He earns $7.50 per hour when he works during the day. He earns $12.50 per hour when he works at night. He wants to earn at least $300 a week. Which graph represents this situation? Okay, so if to earn at least $300 per week, which is what he wants to do, if he just works day hours, earning $7.50 an hour, he would need to work 40 day hours. If he just works night hours, earning $12.50 an hour, he would need to work 24 night hours. So now graphs A and B, what they symbolize, when you look, the most he can earn is 300. Because see, the 40 day hours, it stops there. Or the 24 night hours, it stops. And that's both of these A and B. However, C and D are 300 or more. But what's the difference between graph C and D? Because graph C shows 40 day hours, 24 night hours. Graph D shows 24 day hours and 40 night hours, which is switched. C is what we want because this is what answers our question. So we will go with graph C. Okay, directions. Select the number that represents the region of the graph you want to select. Zach began graphing the system of inequalities shown. Y greater than or equal to 2x, 2/3 x plus 1, 5x plus 6y less than or equal to negative 30. All right, so you could graph this. You could use the Desmos calculator. Let me see, I have Desmos over here. Okay, so y is greater than equal to 2/3 x plus 1. So that's that. Let's see if, okay, so that would be this line here. We see that one. But now we have this 5x plus 6y less than or equal to negative 30. This is in standard form. We need to change, just switch it around so that it's in slope-intercept form so we can graph it. All right, so let's go on over here. Now, 5x plus 6y less than or equal to negative 30. If I subtract 5x on both sides, I'll get 6y less than or equal to negative 5x minus 30. Then if I divide both sides by 6, I get y is less than or equal to negative 56x plus 5. Y, let's see here. Y less than negative 5, 6x. And that said, did it say plus 5? Minus 5. Minus 5. Okay, minus 5. Well, and that's the graph. And now we notice the inequality or the solution for both is in this little spot right here. And when we go back here, 2. That is the region for all the system. See, when you graph them, it's going to be 2. All right? 2. Let's move on. Drag the answers to the correct boxes. Each answer may be used more than one time. Using the inequality shown, create a system of 2 inequalities that can be represented by this graph. All right, let's see. Y blank negative 1/2 x plus 2. So plus 2, so it's this one right here. So this line is shaded above. So that's going to be great, and it's solid. So that means greater than or equal to. So greater than or equal to. And this one is 2x plus 5 blank y. See, that's plus 5. It's a dotted line, so you know it's just a less than, and it's shaded below. So that's going to be a less than. Let's double check that in Desmos. Let me clear this. Clear this. So we have y greater than or equal to negative 1/2. So y is greater than equal to negative 1/2 x. I believe that said plus 2. Yep. Plus 2. And then the next one says y is greater. Oops. I need to switch that. It's less than. Take this out. Yeah. There. Ah. Y is less than 2x plus 5. Y less than 2x plus 5. You see? That's that part right there. All right? Here we go. Right there. Y is less than 2x plus 5. Y is greater than negative 1/2 x plus 2. All right. Let's go. Let f of x equal x and g of x equal 6x minus 1. Complete the statements to compare the graph of g of x to f of x. Okay. So f of x, as a matter of fact, yeah, let's use Desmos for this again. So we'll do f of x equals x, and we'll do g of x equals 6x minus 1. G of x equals 6x minus 1. Now, f of x equals x is here. And then this is the 6x minus 1. So it says the graph of g of x is shifted up, down. Well, wouldn't it be down? Because, go back here. Here, 0 is the intercept for f of x equals x. But negative 1 is the intercept for the g of x. So that's shifted down. Then the graph of g of x is steeper or less steep. Well, to see the way it's turned up, it is steeper than the other. So it's steeper. Okay? Steeper. Yep. It's shifted down and it is steeper. Okay? Let's move on. Let f of x equals x. The graph of g of x is shown. Is this the same? Is this a different question? Well, well, maybe it is. Let's see. Yeah, it is a different question. All right, so the graph of g of x is shown at f of x equals x. Now, f of x equals x is basically going to be just like that last graph. It's going to go straight through here. So, the slope of f of x is 1, and the slope of g of x is 2. So it's going to be 1/2, because f of x equals x is just a one slope. But here, the slope of this particular graph, we can look is up 1, rise 1, run 2. Rise 1, 1, 2. So that's a 1/2. But f of x equals x is 1. So that is going to be 1/2. The y-intercept of g of x, well, the y-intercept is 2 here. We see that. The y-intercept of f of x is at 0. So that means that the y-intercept of g of x is 2 more than the y-intercept. It's not twice because it's 0. Twice 0 is just 0. No, so it's 2 more than f of x. Okay? So, again, the slope, this is 1/2. The slope for the other is going to be 1. So that's 1/2 the slope. And then the y-intercept here is 2. The y-intercept for the f of x is just going to be 0, so it's 2 more than. All right, let's continue. Directions: plot each point on the coordinate plane. A line will extend through the 2 points. Let f of x equal x. Oh, we're seeing this graph a lot here. F of x is straight through here. All right, let's see. The graph of g of x is shifted up 2 units from f of x and 3 times as steep. So if it's shifted up 2 units, that would be x plus 2. And then if it's 3 times as steep, well, the slope is 1. If it's 3 times as steep, that means the slope is going to be 3. Right? So, let's go back here. Right, so shifted up 2 units is x plus 2. 3 times as steep is 3x, so 3x plus 2. So, using Desmos, get this out of here, get this out of here. So g of x equals 3x plus 2. Here's your points. Now, you have a point here at 0, 2. You got a point here at 1.5, or 2/3, negative 2/3, 0. And a point here is 0, 2. So it says plot 2 points to create a line that represents g of x. The coordinate points must be integers. Ah, That's the point there. Coordinate points must be integers. So why don't I do this then? Since you're looking for integers, what I will do is I will use the other calculator. I'll use the TI-84. And then I will graph 3x plus 2. Graph it. Now, if I want points, integer points, I would simply hit second graph. And here I have points 0, 2. I have points 1, 5. I have -1, -1. So I will come back here. I could use -1, -1. And I could use 0, 2. Oh, that was simple, you know, or any of these points here. Yep, that's simple. All right, let's go. A function f is described. F of x equals x minus 2 squared plus 3. The domain of f is all real numbers greater than 0. The range of f is all real numbers greater than or equal to what? Now remember, domain are your x values. Range are your y values. Why don't we just graph it and see? Let's see if I go back over here to the Desmos, and I go. And this is what? X minus 2 squared plus 3. Okay. X minus 2 squared plus 3. All right, so there's the graphing of it. And we see the y values start at 3 and go up from there. So basically, it's going to be the range is going to be greater than 3. 3 greater, right? So, greater than or equal to 3. And we can see that just from the simple graph. All right. Select all the correct answers. Identify each function that has exactly 1, 0. Easiest way to do this, just graph them all. See which ones have exactly 1, 0. Let's start with the 9x squared minus 4. Okay, 9x squared minus 4. Well, it's not that one. That one has 2 zeros. Okay, 9 times x minus 8. So 9 times x minus 8. There's just 1 0 here. So I'll highlight that one. X squared plus 4x plus 8. X squared plus 4x plus 8. Doesn't even touch. So it's not that one. X squared minus 8x plus 16. X squared minus 8x plus 16. Just 1 0 right there. So that one fits. Then negative 2 times x plus 4, x plus 1. Negative 2 times x plus 4, x plus 1. Oops, I put a capital. No. There we go. And there's 2, so that doesn't fit. So there's only 2 that fit, the second and the fourth. There we go. All right, identify each function that has an x-intercept of 3. Again, graph it and see. So this says negative 4x plus 15 over 5. Negative 4x plus 15 over 5. Okay, so this has an x-intercept of 3.75. So that's not it. This one says 3 minus 1/2 x squared. Okay, 3 minus 1/2 x squared. And this has an x-intercept of 2.449 and negative 2.449. So that ain't it. Let's try this. 5/3 x minus 5. Okay. 5/3 x minus 5. And there is an x-intercept of 3. So let's highlight that one. Now, x plus 3, x minus 5. X plus 3, x minus 5. And we see here a negative 3 and a positive 5. So that one's not it. So then this one is 3x squared minus 11x plus 6. 3x squared minus 11x plus 6. And we see an x-intercept of 2/3 and 3. So that one fits. So we'll highlight number 3 and number 5. Now, remember, when you're taking the SOL, if you're taking it online, you can access the Desmos calculator here, Desmos graphing calculator, and it'll pop up for you right there. Along with the straight edge, if you want to make lines with them. Get that out of the way here. And then, yeah, a centimeter ruler, inch ruler, answer eliminator, and pointer. All right? So, which table of values represents the rule shown? The square of the sum of x and 5 is equal to y. I'm going to go back to my Word document here. Okay. The square of the sum of x and 5 is equal to y. So, translating those English words into a mathematical equation, here is the square of the sum of x and 5 is equal to y. And the only one out of these four that fit the criteria would be choice C, because 3 plus 5 is 8, and 8 squared is 64. 4 plus 5 is 9, and 9 squared is 81. None of these others fit that criteria. The answer is choice C. All right, we move on. Yeah, the key is taking these English words, translating them into a mathematical equation, and that makes it easy to solve. Directions: plot each point on the grid. A function is represented by this rule. One more than 1/4 the square of a number, x, is y. And then it says plot 3 points on the grid that are represented by this rule. Each point must have coordinates that are integers. Again, the key, taking these English words and translating them into a mathematical equation. All right, so one more than 1/4 the square of a number x is y. Here, 1/4 the square of a number, one more than that, equals y. So, if we can graph in Desmos here, 1/4 x squared plus 1. Let's see here. 1/4 x squared plus 1. All right, and you need 3 points. Well, one point right here is going to be -2, +2. Another point right here is going to be 0, 1. Another point right here is going to be 2, 2. So, I could plot -2, -2. I can plot 0, 1. And I can plot 2, 2. Those are my 3 points, and they're all integer points. Okay? An experiment is conducted on a container of gas that is kept at a constant temperature. When the pressure on the gas is 30 pounds per square inch, the volume is 120 cubic inches. When the pressure on the gas is 40 pounds per square inch, the volume is 90 cubic inches. Let P represent the pressure on the gas. Let V represent the volume on the gas. Which statement is true about this relationship? Okay, let me head back to my Word document here. Okay, so according to here, it says when the pressure on the gas is 30, the volume is 120. When the pressure is 40, the volume is 90. So when one value goes up, the other value goes down. That's indicative of an inverse relationship. So we need to look at the two answers which have inverse. So if we test the two, it says V equals 4 times P. Well, it works in the first case, but it doesn't work in the second case. Choice C does not check out. But VP equals 3600 checks out in both cases because 120 times 30 is 3600. 90 times 40 is 3600. I get the same thing for both, so choice D is the correct answer once we identified that this was an inverse relationship. Okay, so D. Next, a relation is shown in the table. Which statement is about this relation is true? Now, without me getting really technical on this one, isn't 1 times 10, 10? Isn't 4 times 2.5, 10? Isn't 8 times 1.2.5, 10? Isn't 20 times 0.50, 10? So it's a direct variation because they all equal the same thing. And it's basically 10 equals x times y. Right? Because all of these times equal 10. Direct variation. Didn't really need to get all technical with that one. All right, let's move on. Plot each point on the grid. The coordinates of the points must be integers. The point shown is an element of a direct variation. Plot 2 points other than the point shown that are also elements of this direct variation. Okay, direct variation. You know that everything is going to equal the same thing, right? You should also know with direct variation, it always goes through the origin of the graph, which means 0, 0 is always a point on the graph with direct variation. Now, if we notice, we go up 3, rise 3, and run 2. So, following that same slope, we can get the next point. Rise 3, run 2. Rise 3, run 2. It's a direct variation. There we go. All right. Using the quadratic curve of best fit, which equation most closely represents the set of data? You need to be familiar with how to use your TI-83 or 84 calculator in order to graph these things in order to successfully answer this question. Let me show you what you need to do here. All right, first off, we turn on our calculator. Let me clear this out. Second thing is go to your mode key and you want to scroll down where it says Stat Diagnostics. Turn them on. Enter, quit. Now we need to graph each of these here. So we go to our stat key and we go to edit to punch these in. Now, the first numbers here are going to go under our L1, which is our x values. The second numbers are going to go under L2, which are our y values. So I have -8, enter, -7, enter, -6, enter, 5, enter 3, enter 5, enter 7, enter. You should notice that they're making a circle here, half a circle. Now, right arrow over, I want to put in my y values. So 80.4, 80.4, 57.8, 38.6, 22.8, 18.8, 51.8, and 98.4. Okay, so I have 7 x values, 7 y values entered. Now, I'm going to hit my stat key. Right arrow once over to the calc menu. Since it says quadratic curve of best fit, option 5, quadratic regression. My x list comes from L1, my y list comes from L2, and then I'm basically going to hit enter down and calculate. When I hit enter to calculate this bad boy, so it tells me y equals 1.7x squared plus 2.9x minus 5.2, because that's the A, the B, and the C. That's my A, B, and the C. And it says my R squared, which is my correlation coefficient, is dead on 1. What it means is it is an exact fit. Anything that is close to positive 1 or negative 1 is a very close fit. If it is a dead on 1 or dead on negative 1, it is an absolute fit. So 1.7x squared plus 2.9x minus 5.2, and that's option D right there. Right? And question 28, last one. All right, this table shows the number of months and the approximate distances driven in miles for 6 buses in the school district. All right? Using line of best fit. Last one used curve for best fit. This time we're using line of best fit. Which value is the best prediction of the distances driven in miles by a bus that have been used for 40 months? You notice 40 is not on this graph here, but let me show you how you would extrapolate that data. First of all, we're going to go back. We're going to hit stat. We're going to hit edit. And we need to clear out this data from the previous one that we so we can make room for new data. Hit the up arrow, highlight L2, clear, enter, clear that out. Left arrow, up, clear, enter. So now I've got a clear screen. Okay, let me enter this data here. So 6, enter. 10, enter. 12, enter. 15, enter. 20, enter. 27, enter. So, right arrow over. 10,100, enter. 17,000, enter. 23,900, enter. 31,500, enter. 43,200, enter. 59,900, enter. Now, notice in the Y column, distances go from 10,000 up to almost 60,000. Now, our normal graph just simply goes from negative 10 to positive 10. I'm going to expand my window so when I graph it, I can see these here. I'm just going to alter my window just a bit. And they want to know for 40. So for my x values, I'm just going to go from 0. And I'm just going to change it to 50. My scale, I'm going to make 5. I always make my scale 1/10 of my x max. That way I guarantee to see it inside the window. Now, the y minimum is 0. Y max, I'll do 100,000. And then my y scale of 1,000. All right, enter. Now, let's go over calc, linear regression. Now, x1, x list is my L1 where my x values are. L2 is my y frequency list. Now, store reg EQ. I'm going to do something here that maybe your teachers have shown you. If not, first time you see it, take this. You can use this. Under store reg EQ, I'm going to hit the vars key. Right arrow once to y vars, hit function, and then hit 1. What that does is when I calculate the value, it will automatically transfer it over into the graphing mode in Y1 for me so that I can graph it. So now, if I hit the calculate here, enter, calculate this bad boy. So now what it's saying is the line of best fit is 2,419.71x minus 5,362.44. Bye-bye. Now, since this is a line, you will notice we have an r squared and we have an r. The r is for the linear line of best fit. R squared is for the curve of best fit. Since it says line of best fit, it says 0.998. I mean, that's almost 1. So it's a pretty tight fit. It's pretty good fit. So now I'm not going to write all of this down. All I need to do now, because I did the store reg EQ, all I need to do is hit y equals. It transfers that number over. And because I've already changed my window here to accommodate these numbers, when I go back here and I hit graph, it appears for me, right? Now, using the line of best fit for this data, which value is the best prediction in miles by a bus that has been used for 40 months? So they want to know the miles when x is 40. So what you can do is hit second, F4, which is trace value, and then x equal will blink. So they want to know for 40 months when x is 40. So if I put in 40, hit enter, I get 91,426 miles. So 91,400, that is the answer. Submit. Oh, it just says, and then submit your final answers. Yep, yes, submit final answers. And that's it. It doesn't tell you what the score is, but those are what they are. All right, guys. So, yeah, that's the Algebra 1. And I guess I'll do one for Algebra 2 and for geometry as well. But there's Algebra 1. So if you have any questions, just shoot me a quick email or, make a comment under this video. And have a good day, guys. Talk with you later.